කලින් chapter එකකින් කලින් subject මේ අපි කරා professional logic. දැන් අපි යන්නේ predicate logic වලට. predicate logic අවශ්‍යයි functions ඒ කියන්නේ සමීකරණ process කරන්න මේ predicate logic අවශ්‍යයි. ඒකයි ඒක වෙනම subject එකක් හැටියට තියෙන්නේ. හරි අපි බලමු. It is not possible to formulate functions in the professional logic structure. Hence, predicate logic was invented. Let us look at some preliminary concepts in predicate logic. Let us try to write down the following statements in predicate logic symbols. Let us write down the logic symbols again. So that there exists, may symbol E anipatharola, make a for all, or, and, not, implies, may tunama papottola implies volta පාවිච්චි කරනවා in the provision. If and only if is a member of අවයවයක්. මේ කියන්නේ අවයවයක්. මේ කියන්නේ not, etc. N equals natural numbers 0, 1, 2, 3, no negative numbers. Q rational numbers, numbers that can be expressed as a fraction. මේ විදිහේ 3 බෙදීම් 5 වගේ කරන්න පුළුවන් numbers now fractions. Note, irrational numbers such as pi cannot be represented as a ratio of two numbers. Real numbers 1.11, 3.56, etc. C equals integers. Minus 1, minus 2. First example. Example 1. Making can for all x, px. Again, px function is defined. It was px equals 2 times x. The main samikaran for all x, px exists. Making care. Is this a true statement? Yes, it's a true statement. This means for all x, px is true, correct? Because px exists. Or there is a value for px. The function px is simply 2 times x. Now, how to represent all men will die? How to represent all men will die? Let us define px equals x will die. Px means x will die. So for all x, px. For all x, x will die. That's what it means. Making candy, px candy, x will die. For all x, x will die. Is it a true statement? Yes, we all die. Example 2. Now let us look at the following statement. For all x, px implies not cx. Then px or cx defined kanon. Px defined kanon method. X is married and over 18. Cx is defined kanon. X is a child and under 18. For all x, px, if this is true, for all x, x is married and over 18. Then not, then that person cannot be a child, right? They are back in the implies not x is a child, right? For all x, px is true, then this is not true. Example 3. For all x is a member of E is group of elephants. For all y, member of R, group of rabbits. Pxy. What is pxy? X is taller than y. Is this a true statement? Or all elephants are taller than all rabbits? Maybe, maybe not. I don't know. It looks like a true statement. So that can make a true statement. So above formula can be read as for all x, member of group of elements. For all y, member of group of rabbits. Function pxy, which means x is taller than y, holds. The above statement can be true or false. Make a true and false. Right. Example 4. Let us look at the following statement. For there exists x, member of C. What is C? Group of cats. For all y, here it's there exists. Here for all y, member of R. What is R? Group of rabbits. Pxy. X is faster than y. The above statement can be read as there exist some cats who are faster than all rabbits. That could be a true statement. I don't know. Maybe not. Now let us look at another statement. Example 5. for all x member of n, for all y member of n, pxy, y equals x squared, pxy, y greater than x. This is a true statement, mathematical statement. All x, n equals natural numbers. දශම අයිති වෙන්නේ මේකට. y x වර්ගය විශාලයි, y is x squared is greater than x. Right? For all x member of natural numbers and for all y a member of natural numbers, y is greater than x, where y is the square of x. Example 6. For all n member of z is the integers. For all k member of C, n equals 4k, or n equals 4k plus 1, or n equals 4k plus 2, or n equals 4k plus 3. This is a mathematical statement. Make a satya. The C is the set of integers. Rina eka, rina deka, rina tuna, bindu eka, deka tuna, adi washen. The above statement say for all n a member of integers, there exists k, a member of integers, k එකක් integer වෙන්න ඕන, such that n equals 4k or etc. etc. අපි බලමු මේක සත්‍යද කියලා. Let us consider random number 13 for n. Let us say k equals 3. Let's assume this. So we can see that if it's k equals 3, n equals 13 and k equals 3, then n equals 4 times k plus 1 is true. So one of them, n equals 4k plus 1 is true. K equals 3, 3 වැඩි කිරීම 4 12 ධන 1. මෙතන O තියෙන්නේ. මෙතන n තිබුණා නම් it means not true. Now මේ වගේ mathematical statement piano axioms use කරලා ඔප්පු කළ යුතුයි. මේක තමයි ඊළඟට ප්‍රශ්නය වෙන්නේ. අපි බලමු Goldbach conjecture අපි professional logic යටතේ අපි බැලුවා. දැන් ඒක කොහොමද මේ predicate logic වලින් පෙන්නන්නේ? Goldbach කියන්නේ for Goldbach conjecture says all even numbers greater than 2 can be written as the addition of two prime numbers. For an instance, 20 equals 3 plus 17. 20 සමානයි 3 ධන 17. මේ දෙකම prime numbers. හරි 10 in even number equals 3 plus 7. මේ දෙකම prime numbers. 16 equals 3 plus 13. මේක ඔප්පු කරලා නැහැ. අපි බලමු මේක predicate logic වලින් ලියන හැටි. For all n greater than 2. Right? n mod 2. Mod 2 කියන්නේ mod means the remainder. n mod 2 කියන්නේ n equals 5. mod 2 පහ බෙදීම 2. ඒතර remainder වෙන්නේ 1. n equals 12. mod 2 12 බෙදීම 2. remainder වෙන්නේ බිංදුව. ඒ කියන්නේ මේ n mod 2 remainder එක බිංදුව කියන්නේ මේ even number. හරි ඉරට්ටේ number එක. හරි විය යුතුයි. For all n greater than 2 even numbers implies there exists p and q. n equals p plus q, and p and q is a member of px. What is px? X is a prime number. ඒක තමයි Goldbach conjecture එක. X is a prime number. P and q are prime numbers. P plus q, right, equals an even number for all n greater than 2. මේක තමයි Goldbach conjecture එක. දැන් මේක prove කළ යුතුයි. මේක prove කරන්න පුළුවන් නම් ඉතා ප්‍රසිද්ධ පුද්ගලයෙක් වෙන්න පුළුවන්. දැන් මේක මේ conjecture එක prove කරලා නැහැ. අවුරුදු 500ක් ගානක් තිස්සේ මේ conjecture එක තාම තියෙනවා. ඒක සත්‍යයි, නමුත් ඒක prove කරලා නැහැ. හරි. සත්‍යයි කියලා අපි හරියටම දන්නේ නැහැ. නමුත් ඒක prove කරලා නැහැ. piano arithmetic පාවිච්චි කරලා. හරි. දැන් අපි predicate logic සාමාන්‍ය දැනගත්තා. ඊළඟට අපි බලමු Gödel next section එකේ part 6 Gödel numbering system එක අපි සාකච්ඡා කරමු. බොහොම ස්තුතියි සාන්දු.